All right, so I want to start talking about single responsibility in Unity. Particularly, this one is, while a lot of this is very focused on Unity, the general things that I'm talking about are just SRP overall, single responsibility principle, single responsibility property. I have some challenges to it, areas where it is weaker or stronger, and how I end up using it. And I want to talk about where to identify some of these potential weaknesses because you might not even recognize it, but as soon as I say it, a few parts of it, you'll probably recognize it. Okay, so the big thing about single responsibility is that it keeps your code small in intent, that you've got small code. It has low complexity. So a class, for instance, would be focused on one key area. And there's an example, really the anti-single responsibility principle or property is that, and I'm calling out principle and property because I'm going to be dealing with both Solid and Cupid. And Cupid doesn't exactly have single responsibility property, but I'm extracting it from another part of it, and I'll explain why. But I want to give an example of some things a lot of us have probably seen. I've seen it in many programs. I've been responsible for it a few times myself. Having a single monolithic file, or maybe even several monolithic class files that have huge amounts of code. There is so much risk there. I want to call out a practice, a principle perhaps. This might be a good principle to actually have, but I don't have a name for it yet. The general idea that if you're going to go in and edit a class, aside from maybe just making a very obvious typo fix, but nothing that changes the structure of the code, you should know how that class works. You should have taken a look at what all the functions are, what all the variables are, and anything using the variables that your function is altering, you should understand those inside and out, how they work. So you can understand when you make this change, what impact is it going to have. On top of that, you should have a general understanding of how the communications work between this class and other ones. Something's going to trigger it to do something. It very likely will trigger something else to happen in the means. You shouldn't be making changes to your code or someone else's code unless you have those ironed out. So if you have a game class, a game.cs file that is over 10,000 lines in code, that is an impossible task. You cannot reasonably understand what is going on inside of it. And in many cases, you're not even going to be able to reasonably track out what one variable is being used for. And so you have so much opportunity for spaghetti. You have so much opportunity for this multiple variables actually having the exact same implied meaning in the code. And so depending on where you're coming from or when it's used, one will be accurate and the other one won't be. All right, so giant classes are bad. In general, for whatever reason you have, most people can agree that if you have a giant class that has a lot of different functionality, a lot of different things it's doing, it introduces a lot more chances for bugs. It introduces a lot more chances to maintain it. So single responsibility in any of the four methods I'm going to bring up effectively is talking about reducing it and keeping it simpler. Let's dive into the first one. Single responsibility principle. This is the one that a lot of people are more aware of, but though it isn't necessarily that practiced inside of game development. Back in 2017, I gave a talk at Unite about how to use Solid, and I touted it as really good, something we use we get to enjoy inside of our professional applications, our business applications, or enterprise applications to split apart our stuff so we can deal with larger architectures without getting hurt by it. Now, the thing is that there's some faults here, but let's dive in. What is the meaning of single responsibility principle? Well, Wikipedia copies from the book, and I can't remember what the book was titled, but here's the quote. Every module, class, or function in a computer program should have responsibility over a single part of that program's functionality, and it should encapsulate that part. All of that module, class, or function services should be narrowly aligned with that responsibility. So it's kind of wordy, but Arthur C. Clarke, the author of that original part, later redefined it or re-expressed it, shrunk it down to this. A class should have only one reason to change. Okay, so if you have a game class, game.cs file with 10,000 lines of code, you can imagine that it would be possible to have reason to go and change it for almost any feature in the game that needs changed. That's one key reason to split it apart. You want things to be simpler and lighter, so you want to split these things apart, and that's what this is talking about. It's talking about splitting it apart. Now, one thing is, I've also heard it defined this way, and I used to agree with this, is that you should have one reason to fail. And there is some good definition of that, like some good idea of that, but it doesn't really call it out. That if, say, you are doing something that works with the database, it should have one reason to fail. Now, ideally, your database, if it works great, you're not going to have to worry, but you could get network exceptions. You can get permission exceptions. Those are things completely out of the control of your code in most all cases. You could have version protocol differences. You could have permission issues to the local file system. You could have bad code errors that happen just from the services you're talking to that have nothing to do with anything in particular. It just doesn't work with a variable when it has a comma in it. Okay. So that's a key thing to recognize with this stuff, that it's really about kind of this general change, this one reason to change. Now, let me give you an example. I want to give you an example of a smaller thing. Like, let's say we take out our score code and we effectively create a score manager. Maybe we call it something else. Maybe it's coded slightly differently than I'll describe. But we have our score manager, and it has an integer inside of it that holds onto the score. It has a reference to a UI text field where it can update and display that score. And then it has two functions in it. Reset, which resets a score to 0 and redisplays it as 0. And add score, which adds more score to the value and resets what the UI is showing. That is incredibly lightweight. That's like 4 or 5 lines of real code there. And some boilerplate of like what the function names are, the namespace, the class name, etc., and the using statements. But there's very little code there. It is so simple. It is so focused. But at the same time, one of the biggest failures that I see for most teams using this is the interest in nitpicking on how things should be split apart. And by all means, we are responsible for doing that to ourselves as well. Where we're constantly questioning, should I be splitting this apart? Should I be doing this more? And quite frankly, if you're questioning it, there's two things. One is you probably don't need to, because if you're not sure, you've probably already got it simplified enough in general. And second thing is, if you really do think it should be separated, but it's hard to figure out which one is right, which one is simpler? Which path would be the easier path to do? That is usually the right answer here. Not always. There's always nuanced reasons in all of this stuff. Okay, so nitpicking is one of the common things. Now, I've seen that taken to extremes. So when we're talking about like model view controller, that example where it was like 3 or 4 lines of real code could get split out into 3 or 4 classes. So we have our model. Our model holds on to our data, and so we've got a class that is our score data, and that's accessible from wherever it needs to be accessible. And then we've got another one that is our controller, and that has the function for reset and change. And then we have our view, which is holding on to our UI elements. And so we split those apart into 3 entirely separate classes to do all of what it took, probably a total with all header information, 10, 15 lines of code, with no complication in its understanding. That is a big thing to understand. We implement things like model view controller to simplify things, or MVVM, or SOLID. But there's a point where you go beyond and you add more work than is helpful. Now, if someone needs to change this, they have to understand 3 separate classes potentially, not just the one. Okay, so a side effect of this is that places will have... I've been on a team which every single class was under 100 lines, except for maybe one. It was like 120 lines. But we ended up with over 1,000 class files in it. That's a side effect of taking single responsibility too far. You split things up too much. Yes, well, this one is doing the addition. Well, this one's doing the subtraction over here, so we're splitting those up. Almost one function per class. That's the way people sometimes default to splitting up single responsibility. And that's tough. Managing to call all the data that needs to be passed back and forth, that's tough and can be slower, and there's so many issues you can run into. Anyway, so I don't recommend diving in that far. Now, there's one thing that I want to call out about single responsibility principle that we're going to see across all of this that is a reason why I don't think single responsibility really should be inside of the SOLID acronym. Everything else inside of the SOLID acronym is pretty measurable. You can call out things like, all right, I'm calling on a field in another class, but I'm not calling an interface to it. Okay, great. I know that I need a layer of abstraction between there. That's part of what SOLID calls out. Now, single responsibility it's subjective. It really is subjective. And it changes all the time because of that subjectivity. Because the domain, your single responsibility principle as to whether or not a class is validated under single responsibility is based on a current image of the domain of that project, how that project works overall for the user, how it operates, what it's supposed to do. It's based on that set. So as soon as we introduce a feature that suddenly changes how part of the domain works, almost any part of it, it potentially invalidates that our code was successfully following single responsibility before. Nothing else in SOLID that I can think of right now, though I'm going to reconsider it with this example later as I go back through those ones, nothing else in SOLID really does that. Once something has a layer of abstraction between it and the other class, that layer of abstraction is there. Even if I change parts of either end of that class, that abstraction layer is still there. I can't invalidate it just by changing an obscure separated piece of code that doesn't appear to have any context with it, that doesn't seem to even share state. The only way to make single responsibility stay valid for every class, for every change, is to go through every single class with an understanding of how you just changed the domain model with your new changes in feature, and question with every single class after having studied that class again to make sure you understand what and why it is doing what it does, that you have to go through every single one and re-question it. Every single change. It's very similar. Like, this one is a little bit more of an obvious example of it. But we end up making these elegant architectures that work so great. And then we place so much of our code on it. And then a new feature comes in and suddenly that architecture that almost everything is based on no longer works. That is serious. That's where we start applying these weird hacks. Like, I might have to change 1,000 lines of code in this and in 300 segments of domain knowledge. That is complicated. Putting in a one-line hack, that is easy. But then the domain is the domain plus this hack. Your domain is becoming hacky, and that's a bad practice. I would hope that everyone can generally agree that putting hacks in your code is a bad practice if it can be avoided. There are times where it's reasonable. It literally is, and there's no better way to do it. Okay, but we want to avoid those hacks. Okay, so let's move on to this next one. The next one is from CUPID. It's from single responsibility property. Single responsibility property isn't actually a specific part of CUPID. CUPID is great. Oh my God, CUPID is awesome. CUPID was suggested as a replacement for SOLID. And I think it's a great one. I think it makes a lot of sense. But it's not measurable. It is not easy. It is difficult to apply. Let's give this example. Single responsibility property doesn't come directly out of the acronym, but I'm including it here in reference to CUPID because CUPID has you in it. U stands for Unix philosophy. Unix philosophy is 4 paragraphs of information. Now, it was later shrunken down by Peter H. Salas in 94, but it has 2 lines that effectively apply to it now. Write programs that do one thing and do it well. Write programs to work together. And then it goes on. The third one is actually how to get them to work together, how to work together well, which is write programs to handle text streams, because that is a universal interface, except we're talking about code practices here, so it doesn't directly apply. When we're talking about functions passing information back and forth, I'm not passing everything around as a JSON model, for instance. Okay. So let's move on with this. The first line of it was write programs that do one thing and do it well. That sounds a lot like single responsibility principle, but there is a difference. And they call it out really well. If you want to look this up, take a look at the article. It came out February 10th, I believe, of 2022. So this year, at least at the time this is recording, for those of you in the future. Everyone watching the recording is in the future. How far in the future is the question. All right. So for future use, just do a search for Cupid in all caps, along with programming and Cupid programming, and there was one other keyword that I can't remember. Oh well, I'll have to leave it at that for now. Cupid programming, joyful. That was it, the keyword joyful, and it will find it. It's going to find it as like the first result, I believe, on both Bing and Google. All right. So you take that article and you read through it, and it's kind of beautiful in how it describes code and what it's intended for. But, and it separates out this. It explains how, and you can look at the details of how SOLID is written versus how single responsibility is written. And SOLID is based more on the architecture of code for being code, and Cupid is more based on code supporting domain, that it is split by domain purpose. Because it's very easy in your code when you're splitting it out by code to suddenly split out model view controller, and now your scorekeeper is broken into 3 separate classes. And that's a point where you're certainly overdoing it. Now you can still overdo it with this one, and you can underdo it with this one. Because write a class that does one thing and does it well. That's clear, but it's subjective still. It's not really measurable. Since it's not measurable, it means we're still going to be nitpicking over it. It still means we're going to be arguing over it, even to ourselves. Are we isolating it this way? Now, I will say this, that under this one, we will likely not end up splitting scorekeeper into 3 separate classes. It's likely not going to happen. But that being said, that complexity that I brought up about Cupid, it's a great thing that I want to see happen, but I believe it needs to change. And the fact that there is so much going into each definition is why. That there is so much to just understanding the U, and I only explained one tiny fraction of it. Now, their article has to be separated out because they're talking about why to replace SOLID, so that's a key thing to keep in mind. I believe later, and what should happen soon, is that the author of it or somebody else needs to rewrite that in its most basic fundamental form. Here are our to-dos. Here is how we apply this in general. This is the meaning of it down into like one-liners. Okay. And without that, if you're going to make it bigger than SOLID was, then that's not necessarily a good replacement for it. It's just a different complex thing. Okay, so let's move on. What's a simpler one here? 100 lines of code. This was part of an example of tips that I read back in the 90s. Me and a friend were looking at them, and we kind of looked at each other when we saw this, that any class should be under 100 lines of code. And we were like, no. I mean, first of all, in the structure of VB, all of your different UI elements that you put onto a form have its own item sitting inside of the code, its own separate methods and values. And so if you have a form with 20 things on it, that is automatically at minimum what would that, 20 times 4, you would need at least 4 lines there. Oh, no, with VB, you can shorten that down. It was a little less with it. So I think that was 3 lines for each one. So it's 3 times 20. So you're already at 60 lines for having 20 fields or items of UI up there, or interactable items. And then that's if there's no real complexity to the code for those. So it was really easy to go over 100 lines. Now, at the same time, I understand the general purpose of this, that when you're talking about classes, when you're talking about the organizational structure of a project, that if you're going over 100 lines, that's a good sign that things are getting complicated, that you're adding unnecessary complication to this, and it could be split out more. So I understand the value of it, but I'm going to call this one out, that it doesn't necessarily work that well just because of the fact that it doesn't give us any real rule. It gives us a very clear rule. If you're over 100 lines, think about it. That's all I'm saying with this. Think about it. Once you reach that 100-line mark, basically anytime you're editing a class during a sprint, if it's over 100 lines, you should be rethinking about, is this complicated? Are my changes overcomplicating this? Is it reasonable to split this apart now? The answer is not often going to be yes, but sometimes it will be. And that's a good place to put it. All right, so the last one I want to bring up is KISS. This applies to everything. Keep it simple, stupid. It's something most of us probably have already heard before. At least English as a first language speakers, just because we grow up with it. I'm sure there's a very similar idea in most other cultures and languages. Just to keep things simple. But keep it simple, stupid. We know this one. Now, again, this one doesn't really have any rules to it that we can apply, but it's a set of glasses, a hat that we can put on, a way to think about this. And really, I say a lot of this is all about coming down to, can you keep it simple? And that's go with the simplest route that you can think of and just try to remember and figure out where things can become complicated so you can avoid them. All right, now, what does Dan do? This is the last part. What does Dan do? What do I do? Well, let's see what I wrote. Larger is fine with stronger organization. There's always reasons you can have larger class files. There's always reasons why you might have more things combined into one. Like you could split out a tree view into a dozen or more class files that are each handling individual components and pieces of how that works. Or you could turn them into smaller properties of an individual element or an individual node of your tree view. And so it's kind of a choice, like which one is better? If I put them all together and have these all as properties that are built into it, then that might lead me to a 300 or 400 line code file. If that's the only thing blocking you, do it. They all serve one purpose. They are all focused on one thing. If one thing goes wrong with that, it's how it shows up. Okay. So larger is okay. You can run into larger classes. But you should at least keep in mind that you want to be able to understand everything going on in that class. What it does, how it uses those variables and fields it has. And if you don't, you probably have little to no business actually being in there making changes to it. Okay. X-ray, not required. X-ray, not required. You shouldn't need to look at the code underneath a method to understand what that method does. Sometimes there will be complicated things. But let me give you this example. Let's say we have a static class called image tools. And then I have a method inside called blur. And it accepts fields called image and strength as a double or a float, or strength percent or percent. Anyway, the general idea is you look at that image tools.blur, that is obvious. You don't necessarily know the algorithm of how it works under the hood, but you understand what it's doing. You understand why you're calling it. And it's also pretty safe to say that that's not going to be influencing state anywhere else in the project. You understand these things about it just by the names. Now, in almost every project that I've ever worked on, there have been complicated points where we have double domain. Double domain is a very real thing where I'm working on this tree view that has nodes as a word, but I'm working on it inside of a system that already, inside of its domain, its larger domain that was pre-existing, already has a very clearly defined understanding of the word node. And so now I have node being used twice in my vocabulary, twice in the domain for different things. And it's very easy for the method names. If I were just to say node as what it's doing, something that is doing something to a node, it's not necessarily going to be obvious. And I might need to expand on that a little bit. Also, sometimes you need XML comments as well. But if you need XML comments inside of your code to explain what a method does, that's another good sign, not guarantee, but a good sign that your code is overly complicated. And I'll also say this, the and, if you include the word and in your class name especially, but also your functions, that's a really good sign that you are doing too much in it. Not always. There are exclusions to this. All right, so the last one is avoid architecture. I cannot stress this one enough. You could have the worst, ugliest code in the world and still have a product that works perfectly for what the user wants. It is a dream to work with from the user standpoint. It could be a nightmare to add any new feature to it. It could be a nightmare to try to get any better performance out of it. And you could also have the best, most beautiful, elegant architecture in the world imaginable. Something that makes developers cry when they look at it because of just sheer awesomeness and amazingness. And it could just miss the point of what the users need. And when you start going through what the user needs when realizing it, it could be something that your architecture can't actually handle, as elegant and beautiful as it is. Avoid architecture. So architecture, I'm going to give this additional sample explanation with. Architecture is where classes connect, where two or more classes start to interact with each other, particularly where they're changing state between each other. So there are exceptions to this. For instance, if I am creating a tree view system, so I have that like a file folder of Windows Explorer. So I have that node structure of items and more items underneath those. If I have that, I might be able to put that into my system. That might have 20 classes or 12 classes inside of it. But the only parts that really matter for architecture are the ones being used outside of that clump. That it uses several of them internally, that I can set properties, but internally those properties go off to additional attribute classes that get connected to it and do modifications to how it shows up after it shows up or interrupts, but not something that the user will see. So in that case, there's really only 2 points that the user interacts with, the actual node and the tree view itself, and everything else is under the hood. So the architecture of those individual pieces don't matter as much. They should be tested well. You should know that they work. But in general, your architecture on what things you need to have organized really should just be isolated to the things that are kind of separating these sections of state control inside of your system. Okay. Now, this is part of a series, and I want to call it just a couple things after the fact here. So this is part of a longer series. So at the bottom, if you haven't already seen this, this is part on my channel. Go click into my channel and look up the Architecture and Unity series or playlist. And it will, I have especially the first video talking about what I do for architecture overall. This is part of it, but this talks about reasons why I don't tend to trust Solid anymore. Now, some of the statements I've made, developers might view as scathing, as blasphemy, speaking in the face of Solid. But I'm hoping that certain things like nitpicking within simplicity, for the simplicity of single responsibility, is something that almost all of us have done. And that we have probably seen things get split apart, or large number of classes start getting split out, where different things in the application are now becoming more complicated because we are trying to follow Solid. or because we are trying to follow even other frameworks. So I think this needs to be one of our core rules, that single responsibility, it's not really single responsibility, I think it's simplicity. And it's harder to define what that is, and that most all of this is not measurable, which makes it tough. But we need to understand that. So please, I'm sure you have opinions on this. Please post what they are. If you've seen challenges or things that I've brought up, and you can express more examples of it, please add that. I'd love to hear about it. If you have challenges to this, where I've said this, but I'm missing the point of something, bring that up too. Those are all valuable. They all do something useful. So, and I'll probably be replacing this video with something else in the future. I'll put a link. I'll put a thing right at the top, at the front of it when you start watching it that says, "This video is outdated. Go look at this other one." Because I very likely will find some point why this one fails in the future. But for right now, this is what I use. After 30 years of experience and studying this architecture and trying to get the best out of it that I can for me and teams that I've worked with, this is what I've come to on it. So by all means, I'd love to get your insight on it. Please share it and let me know what you think.